Okay guys, so in this video we are going to talk a bit about React testing, so let's get into it. So I had this subscriber question where this person was reaching out saying that I really struggle with just Enzyme, best practices, things like that, and I have a hard time doing testing with Redux components and sagas and so forth. Can you make a series about that? And I figured, yeah, sure, I'll put something together. So in this video, I'm probably going to make this a two-parter because there's a lot to cover. So we're going to take the first video here is going to be about us taking a look at components and testing a component, and then the second video is going to be about end-to-end testing. And I think that it's important that we understand that both these two things are necessary to do a really good job when it comes to testing, because there are certain things that are very easy to test at the component level, and there are things that are much easier to test in a flow or an end-to-end type of thing, and we'll touch on that in the next video. So the first thing I'm going to claim is that I'm going to basically state this to you. I'm going to say that the focus of a UI test or a front-end test suite is to figure out if the behavior of your application or the experience for the user is the correct experience. Now, the problem with experience is that when you have complicated structures such as CSS and like visual components, and you have click interactions and you have things moving on a page or animations, things like that, these things are almost impossible to capture in a sustainable way, at least inside of just unit tests. Because unit tests, they were really well designed for one specific thing, and that was to test that a function or a piece of logic does something in the correct fashion. But when it comes to timings, and you might have delays and other things like that, it becomes very quickly kind of clunky to build these sorts of tests, and I think that these are the sorts of things you want to test through an end-to-end tests. But we're going to look at that in the next video. However, the problem with end-to-end tests are that they are very expensive. It takes a lot of time to execute all these tests, because what you're basically doing is that you're starting up a browser, you're starting up your system, and then you're actually doing, through a computer is basically going through and clicking and interacting with the page just as a user would. So the rule of thumb here is that we want as few of those tests as we can possibly have. They should still cover all of our use cases because they are the most valuable tests we have, but they're very expensive in execution. So keeping them low, or keeping them to the bare minimum, is ideal if we can. But we shouldn't avoid them because they're actually better in many ways than most other forms of testing. However, in order for us to minimize the usage of those tests, what we really want is to have a strong suite of tests at the component level. So I'm going to show you a few thoughts that I have regarding this that has been very helpful for me. So let's have a look at the application first and foremost, just to give ourselves a frame of reference here. Let's have a look here. So I have this amazing application here that I refresh here, and you see here that, oh yeah, I can input some information here, and I can see that my login failed, or I can actually log into the thing, and then I see my amazing little application here where I can input some stuff into it to do, and then I can hit log out, and I'm actually logged out again. This is the entire application. But it has enough components to it, so it should probably help illustrate a few of these ideas that I have. So let's close all of this down here, and here you can see that I only have a handful of components here. So I have my main component here, which is my React component, where I have my Redux provider with my store and all that stuff, and a router with 2 routes, and then I have my reducers, these things here. And yeah, that's about it. And then I have these components here. So I have a to-do list, a test utilities. This is just, we'll touch on that in just a moment. This will be clear. And then I have a login page, a home page, and button. And that's about it, really. So what I will do state now is that in general, there are a few types of components that we will build. And the biggest difference between them is going to be basically how we think about their use case in terms of testing. So if I create a button component here, now odds are that I'm going to want to have the same button component pretty much everywhere. So this is a very, very simple button, but you can imagine, like, I could have some styling going on here. I could have different variants. It could be primary color, secondary color. It could be different fonts. It could be all kinds of stuff, right? Now, if the goal for me is to create the most consistent UI that I can possibly make, I need to make this a standard component. In other words, it has to be a component that is so flexible that it can be used everywhere. I don't want my coworkers or my consumers of this button here to have to add their own styling if I can avoid it, because odds are that they will create their own custom thing, and that custom thing becomes untested code. Very likely, or even worse, well, that's the worst case actually. It would be better if they created a custom button somewhere else with some styling and then they kind of tested that as well, but I know people, and people usually don't do that. What usually happens is that, it's just front end, so hey, I'm going to add some extra padding to this standard button here in my specific case here, and then I'm going to create that inconsistency. I'm going to go on with my life. But what you want is to create this very flexible interface where we can extend on this standard component, or ideally make a standard component that is so well designed that we don't have to force people to customize it. How can we do that? Because one of the hardest parts about this is that, all right, if you have a standard component, odds are that that's going to be reused a lot, all over the place. So it's extremely important that we have good test coverage for this. Now, I've only created a few base tests here because if I wanted to create this into a really standard component, I would have to put in quite a lot of energy into that. So I've just created a base suite here. But I want you to take away the thought from this rather than the actual implementation. And the thought that you should have is that when you define a standard component, you should have a base suite of tests that asserts what you do, that's going to be common for every single standard component that you have. Now, I have one such thing. This is a very simple suite where here in my test utilities, and all this is just a standard suite of tests that will apply to, it doesn't matter if it's a button, it doesn't matter if it's an input element, it can be anything that is a standard that I want to standardize is going to use this in some fashion, or like it's basically just a sanity check. So all it's going to do is it's going to check if it's defined, the element, and then it's going to try to render it out and just make sure that it actually can render something out. And then finally, it's just going to check if it matches the snapshot that I have created. Now, snapshots are an extremely powerful thing because snapshots allows us to basically render out the component in different states. And why is that important? Well, because what you basically want is to have a test suite that makes sure that you know the different start states a component can exist in, and that the DOM that gets rendered from that component is always consistent with what you expect it to be. Now, in my button example here, it's kind of straightforward. I don't have to input anything here. I just say, okay, button, this is my test, and it should render out an empty button. But I could also go and do something like this. I could say, all right, and I could say button like that, and I can say foo. And now I have a second test that actually makes sure the same thing. It just goes through the same thing, and this time it's going to create a snapshot. We can actually see that in action. So it should now basically say here that, yeah, another snapshot was written. So I created a second snapshot just now. And I probably want to change that name, but it doesn't matter. So the snapshot that's going to be created now is this thing here. So now I have a snapshot that checks that, all right, my component, it will be consistent with what I expect it to be if there is no input. And then I also have a case for a snapshot where if I put in some text, it's going to render out the right thing. I could even go further and I could create an element or something like inside of here, and I could start to pile up these different snapshots of how I think that my component should be when it's just rendered. It doesn't have, nobody touched it, there's no click, there's no change to it, it's just plain rendered to the DOM, right? Cool. So let's remove that, and then I have one standard component based tests, or like a function here, which is, you don't have to make it into a function, but I think it's very efficient if I'm gonna, because this is also going to be true for every standard component that I want to make. And then basically all I do here is that I create this test that it just creates a custom attribute, and then it uses an onClick function because every element pretty much has an onClick. You could make it something else, but I just like this. And then we shallow render with Enzyme, and then we simulate a click on the element, which is my favorite use case for Enzyme just in general, but we'll touch on that in just a moment. And then we just assert that we clicked it, and then we clicked it once, and then finally we do a check for the custom attribute on the element that we like our component here, and just make sure that it was actually passed in correctly. Because something that often happens, and this is a bit of an opinionated thing, some people forget to do this sort of thing, or to like pass through all the other properties, and that's not, it depends on your viewpoint, but I think that you should do this, because otherwise you might actually limit the flexibility of the component. It's very frustrating when you try to add a custom attribute or something like that, and some person hasn't done this sort of spread. You can do it nicer than this, so you don't just blindly do what I'm doing right now, but as I said, this is a simple component. I would put much more energy into it if it was a standard one. But to have that idea that you have some type of test here that just makes sure that the sanity checks and like the most obvious things are taken care of in your standard components, because remember, if they're going to be standard, they have to accommodate all the different needs out there that you want to allow for. And maybe you don't want to allow custom attributes, but I want to allow custom attributes because I have a very strong use case for them when I work. Anywho, apart from that, then I have these base tests, and I would create even more functions. Let's say that I wanted to create I could create another suite of tests that just checks different types of input. If this wasn't a button, it was an input instead, I would probably create a standard suite of tests that just checks that, all right, this is an input element, and I expect that it's going to have type something something, and I expect if I type into it, it should have a value inside of it that it corresponds to the thing that I just typed in, and stuff like that. So building up these layers of standard tests for your components when they're supposed to be standard components is a good idea. And then of course we have the things that are specific to this exact component, right? Cool. So this is just the base idea of this, and having this with you I think is very important, that when you create a standard component, it is vital that you test every single granular, like every interaction you can think of, like absolutely everything, because if you don't, you're going to make a lot of people nervous if they need to update your component and they don't know what's going to happen if they change something and it's going to break on some other page, right? You can think of this code here, like these tests, as the documentation of the expected behavior of your component, right? And here I have a to-do list now. Now this is not a standard component, so my mindset here is going to be a little bit different, but I'm still going to try my best to like test it properly and so forth. It's not as important. Like the problem here is that when I'm making a standard component, I need to test pretty much everything, like really go granular on everything from click interactions to properties being passed in and everything being consistent. But when it's a bigger component like this, I personally find it harder to justify that level of granular testing, because as a component grows, it becomes more and more complicated. And in theory, if your components become standard, you shouldn't have all that many of these one-off components. And ideally, you should capture these larger components with more complicated behavior into end-to-end tests, and we'll touch on that in the next video. But this is like the basic components. So I have a container here where I just pull in, as you can see here, the standard stuff for working with Redux. I have my to-dos, and I have a maps dispatch to props where I have some functions, and then I connect them all together into my component. Here is my component, which is just a to-do list. It has a component will mount where I actually get all the to-dos and I put the to-dos on my Redux state. I have an onChange handler inside of here because I have some internal state where I want to show that the user is typing for some reason. Let's to be honest here, it's just for demo purposes, but you know, in a networked world it could have been useful. And then I just render out my to-dos like this. It's hopefully a very simple component with an on submit and some stuff, right? So let's actually look at this as well. We have some events, and then we have a reducer. Cool. So the tests that I create here are these tests here. So I have a component test itself, which is this thing here. We're going to just walk through that in just a bit. And then I have a reducer test, which is the second part of this. So when I'm creating a reducer, like my general rule of thumb here, and I hope that you will take this with you, is that I avoid as much as possible having impurities in my reducer, because I want my reducer to just be a dumb function. I just want it to take some input and spit out a new output. It should only be responsible for that state mutation. I know that I can use Redux Thunk and like Saga, and like there's all these other libraries that do some type of it allows me to send asynchronous code into my reducer and have that being resolved internally. I never do that, ever. Like, if I can avoid it at all, because the problem with promises is that they are unpredictable. I lose control over the logic that is inside of my reducer. What I usually do is that I put it on the call side. In other words, it's the component's responsibility to resolve the promises to a value, and when the value is inside, it has been resolved, then you can dispatch. You don't dispatch the promise. I don't do that because I don't want promises inside of my reducer. I only dispatch values. And when I do that sort of thing, it becomes very easy for me to test it because it's just a pure function. So here I have a few sanity checks for my reducers. And these are just a standard test that I think should be on every reducer. Okay, I check that it is defined, and then I check that it's going to return the same input state that I inputted. If there is an unmatched action that doesn't do anything, right, then it should just give me back my original state. And then it should also return an initial state if none is passed in. So these are just some simple sanity checks I'm adding. And oh, I lost my place here. And then we have the actual component tests. So here we'll see an example of what I was telling you about earlier. So I have my component sanity checks here, where I basically am passing in two different types of render state. So I have a to-do list where there is one item, and I have a to-do list that is completely empty. And then I just render out and snapshot them, and I can see that, oh, okay, they're actually the thing that I'm expecting, because I'm assuming certain things about this. So apart from that, I'm also passing in my getToDos, which is an impure function. But here, when I'm just rendering things out, that doesn't really matter. I just need to pass in an empty function or something like that, so it doesn't actually invoke itself. And the same thing goes for the onSubmit. Like, when I'm just doing render tests like this or snapshot tests, it's very efficient to just, the component really only cares about data in this scenario, so I don't have to have any logical functions or anything inside there. And this is where a lot of people might get a little bit confused, and I suspect that this is one of the problem areas for this person who reached out regarding this. You see, if you put impure code inside of your component, in other words, if you start mixing this logic in here, you can see here that I'm getting my to-dos from the network, parsing some JSON, and then I'm dispatching. Same thing here, I'm pretty much doing that. If you put that inside of here, all of a sudden it becomes very hard for you to just render this out, because you have all this internal impurity going on that is going to determine what DOM structure you're going to get when you render this. So by keeping this pure without any side effects, it becomes very easy for me to just write a test for it, because I can separate my concerns. I can separate the view or the state of the DOM, which is this thing here. It is okay that I use the internal state, because this it's not impure. It doesn't have some dependency to the browser. It doesn't have a dependency to a network or anything like that. It's just an internal thing, and we'll see in a moment how that works. But that's the thing I really want you to focus on here. This is a pure component. It's not a pure function component, like in the sense that React defines it, but it is pure in the sense that there's nothing happening here that I'm not in control of. There's nothing inside of here that I need access to from the outside. If I had put my getToDos logic, the fetch function and all that stuff inside of here, I would have been in a bit of a problem, because that means that there's now impure logic that is depending on the execution context that I don't really have access to. I don't really control it. But by doing this, I am in full control. Cool. So how do I then capture this stuff here? Well, that's actually pretty simple. So you may notice that I'm actually exporting this. And then I have this thing here, which is like, because usually it's just a dispatch function that takes a dispatch, right? But I go one further, and what I do is that I create a higher order function that takes in the fetch function, this thing here. And you can see here at my connect site, I'm actually just referencing the global fetch function. Now, there is no global fetch function in Jest, but there is a setup that I can initialize, which is this thing here. So what I do is that I create a global fetch function just to accommodate that initial render, so that I actually can create the connect. I can actually wire everything up. And then I just pass it this global fetch function that's it's just gonna throw an error if it is invoked, because I don't want a global spy function that asserts if a fetch was called or something like that. I just want this to accommodate the interface when I am instantiating my container component like this. I just want this thing to exist in the global context, but it's never going to be invoked. So when I actually, because when this is running in the browser, this is actually that initial fake function you saw earlier. That's not going to be there. It's going to be the browser's fetch function in that execution. So what this allows me to do, we'll look at the enzyme stuff in just a moment. What this will do is it will allow me to do something like this. So now I can create a fake dispatch function. I can clear the state of my dispatch function so that I can assert things and then I clear it every time in between. And then I can do this, which is my favorite thing to do, because this is pretty much saving me the hassle of having to have a rewire. It's saving me the problem of because I own the fetch function at the instantiation of my my dispatch logic. I can do whatever I want. I can pass in anything, and that's exactly what I'm doing. I'm just creating a fake fetch function that is going to return a fake response that it's just an object with a fake JSON function that returns a static value. And then I can instantiate my map dispatch to props object, as you saw, that the thing that is actually going to be used by Redux. And I can just pass in these two functions and get out the function that's going to be invoked when the user is actually interacting with my component. So this becomes super trivial now. I can just assert the input to my functions. They're not going to the network. They're not doing anything weird. I don't have to use some magical variables or some special library that stubs stuff off and like all of this stuff. It's just a function. I just created a fake function, passed it in, ran my logic, and I just asserted that everything works without any impurities, no asynchronicity, anything like that. It is dirt simple in my world. Same things for the onSubmit. Here it's a little bit different, because in the onSubmit I have an event that I pass in which I need to call prevent default on, and I have some value that I need to extract, and yeah. But you see here that I don't have a response, and then I just dispatch my action, and that's pretty much it, really. And I do the same thing here. I create my event, a fake event, with just this function here, and the same thing goes for my options. And then I create a fake mock function, I instantiate, create my onSubmit, call it, and then I can do my assertions. Easy peasy. And because I have separated this logic, and then I have tests for my reducer, I don't actually have to test with like the store or anything like that, because all I really need to make sure is that this function, when it's being invoked, that it's actually being called with the correct action. And since I have a test for my reducer that checks that if I create an action and send that to my reducer with the correct label, it's going to work. By having these two tests here, I've covered the entire Redux flow. I now know that all of this is going to work together without having any need of some special magical library. The one thing that I should do, which I noticed that I didn't do now, is that I should create just one single. Actually, I do have that. Sorry, I forgot. I forgot about my enzyme tests. But let's move on to the enzyme tests then. So, when do you use enzyme? Well, for me, Enzyme is a perfect use case it has a perfect use case for when you have a pure component and you want to just assert a interaction with that pure component and check that a function was called if you clicked something, or that you want to check that the DOM changed states or something like that internally if you interacted with something. And this is super easy if you have a pure component, if there's nothing if you're not depending on some impurity inside. As you can see here, in my first test here, all I'm doing is that I'm going to check that the display message is, when a user is typing, is actually firing. So I create my wrapper, I shallow render, and then I find the input, which is where I add my to-do. I create an onChange event that just inputs test input, and then I update, so I re-render my component. Then I go and find my paragraph and the text, and then I assert that this is working. And here it is, exactly the feature that I wanted to check. So now this text is visible. Second test scenario, I do pretty much the same thing, but this time I type I remove all of the values inside of my input. I re-render again, and this time I'm going to check that that paragraph isn't there anymore, because remember, from the component, it's only supposed to be showing if I'm typing something, and that is only going to happen if there's actually something in my input field. And then lastly, I have one test here for my onSubmit, which is, this is where this becomes so elegant. I love it. So I have this onSubmit that I want to check. I don't want to check this. I'm a bit lazy here with the on mount, but I could check that as well if I wanted to. So I'm just checking that the onSubmit function is a fake function, and then I input some test input, I update, and then I find the form, and then I submit it, which is the same thing as if I were to hit enter. And then I just check that the onSubmit was actually fired. So if we think about this now, through these tests, I have asserted that, all right, I've checked that when my component starts with a few to-dos, it's in the right rendered state, like the DOM is in the correct state. I have checked that if a function, if my onSubmit function inside of my container here gets fired, this thing here, if this gets invoked, it's going to call the correct fetch function, it's going to go to the network, it's going to do all of these things, it's going to dispatch to my reducer, and thanks to the reducer test that I have here, then it's separated, it's just a pure function. It's super easy for me to just make sure that, oh, if I get an action that has this label, then it's going to do the correct mutation. And then finally, I have a enzyme test that just checks what, if I input something into my input form here and I hit submit, then the submit function is actually going to be invoked. So by separating things in this fashion, it becomes very, very easy for me to test all the parts that make up a component. As you can see, this is a lot of work, and it's a lot of code to achieve this, and that's why I'm saying that you should do this for complicated things, but on average, if you can get away with using an end-to-end test, it's a lot more efficient. So to showcase that, I'll show you how I do with, say, the login page. So in the login page, I don't really have anything but the reducer checks here. The components looks like this. These are my events, and this is my reducer, and here are, like, here's all that logic, right? So, you know, if I was a good camper, I would do the same thing for this as I did for the to-do list. The reason why I don't is because I don't feel that this functionality here is, I mean, the to-do list is a subcomponent, and maybe in a way I still think that the thing that I did for the to-do list was more for you guys to just illustrate this idea of the separation of concerns rather than something that I would do in real life, because I've found it to be more efficient to use end-to-end testing for components that are part of a feature rather than just some individual part of the entire system. So we're going to look closer at that in the next video, but what I want you to take away from this is basically that if you create a standard component like a button, you really need to make sure that every simulation is tested against, every single property is being passed in correctly. You really need to put some extra effort into that, because that is a high value component with a lot of risk if it goes untested. And then you have just this pattern of writing tests where you separate your components into the business logics as part of the component and the actual view, which ideally should just be completely pure, because that makes it so much easier to test everything afterwards. And then you have a very simple reducer test or something like that, and then the rest of it can basically be done with snapshot testing, using some interactions with Enzyme to verify the internal state, and then using this stubbed function approach that I showed you makes it very easy for you to do all the impurities. And in the next video we're going to have a look at capturing that stuff that is almost impossible to capture through this sort of testing.